Welcome to London's Calling again. Hopefully, so far, so good for everyone. Having a good time myself, catching up with friends old and new. So, my session, title up on the screen. I'm guessing everybody is experts at reading. But I want to talk to you about unlocked packages and how they're a great enabler for helping you kind of aim towards that modular development approach, which, as we'll discover, is a great way of working. So, me, who am I? What do I do? Why am I even here? Questions I asked myself when I woke up at 5:30 this morning with a slight headache. I am a DevOps advocate at GearSet. Hopefully you saw us in the demo jam earlier. But before that, I was a Salesforce developer, architect, general dog's body, much like many of us working on Salesforce orgs. And the only plug I'm going to drop in today, I wrote a book about this stuff. So if you want to learn a little more about Salesforce DevOps, not just unlocked packages, and also not just for architects, take a look at that one. But enough about me. What I wanted to do is delve into what I talked about earlier, which was modular development. So I think really this approach is very much at the heart of Salesforce development and how we approach those larger projects and those larger tasks. And unlocked packages in Salesforce is really going to help you achieve that. So what I want to do is give you a few insights, a little bit of practical knowledge about unlocked packages, and kind of just see how, when we talk about modular development, that it's not just a buzzword, it is actually something that we can go away, take to our orgs and architect things in that kind of fashion. It makes it more flexible, it makes it maintainable, and if anyone was in Chris Emmett's talk just a moment ago, it makes them much more scalable. So we're going to look at that, we're going to look at the benefits of how we look at the deployment phase and the build phase of delivering that modular approach, and how they will kind of work together. So let's have a quick run through of the agenda, some of the things I want to talk about. So I will introduce those unlocked packages, what they are, why they're useful, where they fit into the wider landscape of your development and deployment lifecycle. We'll then touch on version control. Version control is absolutely essential to keeping track of all the moving parts. If you've got a modular system and you've broken things into these little modular components and packages, you want to know, okay, this package is on this version, this one's on this version, this one depends on that version. You want to make sure that you've got everything all in alignment there. Which neatly takes us on to that deployment management. We'll look at some of the ways that we can actually, dependency management. We'll look at some of the ways that we can make sure that everything plays nicely together, not just between our packages, but with other things that are already in our Salesforce orgs as well. Then we'll talk about package promotion. No, packages are not getting a pay rise. This is basically how we move them between environments. So moving our built-out packages from dev to QA, UAT, production, etc. It's not too bad. It's no change sets, which is a good thing. But there are a few little nuances to that one. And then finally, a phrase that I'm not actually a big fan of: best practices. I've put it into my slide. The reason I don't like that phrase is because what's the best practice for my org might not actually be applicable in your org, but it's certainly some indicators of behaviors and patterns that we want to be looking at that has proven to be useful in a lot of orgs. But do take the words best practice with a pinch of salt. Make your own decisions based on that. So let's get into it. Unlock packages. At the heart, it's a delivery mechanism, but I like to think of it more as a means of being a mindset for how you develop these things in the first place. Delivery is kind of last mile of any development lifecycle process. What you want to be doing is thinking about how do I group together and move that metadata and code and all the components that make up a Salesforce solution in a way where there are reduced dependencies or dependencies that are actually more controllable and things that are isolated pieces of work. And the reason for that is that it brings a whole bunch of benefits to the table. You can have a much larger code base in complex orgs, but you don't have to have the whole of that code base in your development environment. You don't have to have all these sort of interconnections and intricacies in your head, which is the worst place to keep any code. It means that if you're working on the part of the system that deals with payments, you can do that in isolation. You don't have to worry about opportunities. You don't have, all these different tasks that you see in a modern business. You don't have to kind of grab everything and see everything and deploy everything because you have a much more modular approach. But the other advantage of that is it makes it much safer and simpler to develop, test, debug, deploy, and fix any issues that will come up because again, you're looking at a very specific subset of functionality across your wider org, your wider business, and it makes it much easier to do things like that, as well as things like rollbacks and stuff. Speaking of rollbacks, has anyone seen the news today about computer systems going haywire? Yeah, good case for rollbacks and backups and being able to fix things in isolation quickly and responsively. So, large-scale Salesforce implementations are often the the key case for modular approach to development. The slides moved forward on me, I think. No, I wasn't in the right place. So you get those large enterprises where there are many. You may have a module for HR, one for finance, one for sales, one for support, and that's kind of where we typically see the modular approach to breaking up our Salesforce orgs come into play there. So to bring this to life, what I want to do is look at a real-world use case. It's not as complex as one of those big corporate things, but I think it's kind of an interesting use case and one that I genuinely implemented before I moved out of development and into speaking for a living. So the use case is, I had a customer that was using Salesforce Field Service. They wanted some custom functionality where they was able to embed images into their field service reports, as you can see on the screenshot there. This was something that was not native to Salesforce, well, at least last I checked. It was an additional piece of functionality. It was very specific to field service. It was a good candidate for being a module, an independent set of components, like a bit of code, a bit of component, fields, etc., that very much lent itself to this modular approach and hence a packaging approach. So let's have a look into that a little further. So the first thing I did was make a repository. I will be sharing some links to this so that you can kind of have a look at how it works. But version control is a fantastic first step for thinking in that modular way. So what are the pieces of this puzzle that I'm going to need in order to build this solution? As you can see there, hopefully, it's not too small. I have some classes, I have some custom metadata, I have triggers, components, all the usual metadata that we have. By putting that into source control and having it in separate folders and being able to kind of navigate that on a tree view, you're already kind of thinking in a modular approach for how do we deliver this, because I need to pick out little pieces of those various pieces of metadata and code and components in order to deliver that. But far and beyond that, it means that we can keep track of what version of our changes we're on. It allows us to have a safety net if we need to do rollback, if we need to go back to an earlier version. It allows us to bake in that whole DevOps lifecycle. So source control is the technological beating heart of DevOps because it enables all the other technological features. You can't do CI/CD pipelines and automation, etc., unless things are in version control. You can't do automated running of testing and things unless it can pull it down from version control. So really, when I start this, the first thing I do with a project is I make a Git repository, and I make sure that I have if I have an existing larger repository for my entire org, then I'll create a feature branch. I'll talk more about branching and all the lovely little bits of DevOps in a moment. But it gets you into that mindset of thinking of, okay, this is an independent work stream. Again, we're thinking modular here. So I'm going to create a feature branch. I'm going to split off my main piece of work, say this is where I'm working on that feature. So in our GitHub repository, you'll see that I have broken things up a little bit. Apologies for keep looking around like that. The screen is somewhat off-center for me. But you can see there, if I amble over this way, I have a little subfolder here, image handling upload. Okay, so when we talk about uploading those images in that field service scenario, I want a component, a module, as it were, for handling uploading those images. The actual implementation of this project was that you would upload an image to Salesforce, and it would intercept that, move it off to AWS S3, where storage is somewhat less constrained, and dare I say it, cheaper. A lot of these customers that are very image heavy were running out of storage very quickly. So the whole image handling and all the code that hands off to AWS S3 and manages that and crops, trims, and all the bells and whistles sits in this project. Now, equally, when we get to the report, you saw the little screenshot briefly earlier, we want to be able to render that back out. We want to pull the image from S3, stick it into a formula field, render it on the form, etc., etc. So I've got a separate package down the bottom here, image rendering. So already, we're thinking modular. If I want to change it, say for the sake of argument, I want to change the image handling upload to upload it to Azure instead of AWS, or I want to integrate with our sponsor's box. I can do that. I can change the upload component. I might not need to change the rendering component. In reality, I would, but you can see how you can kind of think around these kind of modular component-based approach and say, okay, I'm going to work on this bit, I'm going to work on that bit. They're dependent on each other. If I update one, do I need to think about, does this version of the renderer require a minimum version of this? Are they compatible? So it's almost like sort of other pieces of development build systems. If any of you have had the let's be neutral about this. If any of you have had the experience of working with things like Python, Ruby, Node.js, you'll know that you download packages. There's like a little manifest, and it says you have to have this version of that. It's all that type of stuff, but for the Salesforce world. So as we talk about those dependencies, let's have a quick look at how we manage those. So again, we talked about we have the image upload component and we have the image rendering component. So here's my little piece of JSON, which is kind of how we define these dependencies. And we're basically saying, okay, in this one, my package here, the image rendering package, is version 0.1. Sorry, that's the name. That's the version number. The little keyword next there just kind of incrementally does it every time we build. But you can see here we've defined our dependencies in a little block. In order to use the image rendering package, I need the image handling upload package, and I want the latest version. So you can see that very quickly you can start building out sort of what goes where, and like for each component, each dependent package that we have, what's it going to need in order to be able to operate? Okay. Now, there is a twist in the tail here. These are unlocked packages, and we'll talk about the specifics of those in just a second. Sometimes, it's more so if you're working with other people's orgs, you may not know what's in that org. You may not know what packages are in there. And there is something called org-dependent packages. Org-dependent packages is a means of offsetting or sort of offloading the responsibility of those dependencies. You're not defining them up front. You're making an informed decision that you expect this to be available in the target org, not the org that you're starting from. So the idea being is that, here, if you think about the timeline of any delivery project, timeline running left to right, normally in all things DevOps, in all terms of building and things, you want to shift left your testing, your dependency management. The more you can do up front, the easier life you'll have with deploying these things. We know that's not always possible, and that's why Salesforce have these org-dependent packages. You're shifting some of that dependency management stuff right a little bit. Now, managing the dependencies has two key aspects to it. So here you've seen kind of how I've defined them. Not the greatest example in that we only have that one dependency, but if you can imagine you've got a package that has dependencies on 8 different packages, for example, you also want to think about the sequencing of those dependencies as well. And again, the order that you're putting them in there are the order that it's going to start looking for those. So having delved into how we manage the dependencies, how do we get our packages out the door? Well, we're back into more config files. This is a very sort of command line and developer-focused way of working. But the good news is for the declarative and admin folks here, get your developer to build this for you once. You probably won't have to touch it again. But basically what it's doing, this is a GitHub action. There are many ways of handling this. This is quite a common one. But the idea is that when you put your changes into your Git repository, when we talked about the version control here, we can then kick off a job that says, okay, the new changes here, start building this. And we're just using Salesforce DX, the command line. We're just automating that a little bit. So very quickly, it builds up a Linux virtual machine, because that's how GitHub works, just so that it's got somewhere to run Salesforce CLI. So it builds the machine, virtual machine. It installs the CLI. It logs into Salesforce. It creates a new Scratch org for us. It deploys the dependency first. Okay, so it looks at what it needs in order to build these things, and it will it'll install that first package, it'll install the second package, and then this is just a shell example. It'll run some tests and then just clear itself down. So it's not doing a deployment in this particular example. What it's doing is building the environment. And when I talk about dependencies in this example, the dependencies are, I need somewhere to run Salesforce DX, I need to install Salesforce DX, I need to log into my org, I need to install my packages, and I need to check them. It's a very basic shell, but you can kind of see the pattern of automation here around, I have these things available in my source control, I can go and fetch them, and I can act upon them when they change and start building out my packages. So as we start sort of getting towards the end of this, I want to kind of talk about how we bring those concepts together. So unlocked packages is the how, modular development is the what, and what brings it together is the why. The why that we talked about here is being able to work in a much more feature-driven approach to Salesforce development. We don't want to be hopping around the org, pulling a little bit of this, a little bit of that. We want to focus on the task in hand, but also we want to make sure that we have better management of those interoperations. Now, that's not always easy with the nature of the Salesforce platform, depending on what we're doing. If you look at some of those core standard objects like account, contact, opportunity, case, lead, all the big ones, you're going to find that there's a lot of things that touch on that. Now, what I've seen with a lot of people that take this modular approach is they will have a base package that has that kind of common functionality, and then the unlocked packages, the special features, the secret sauce that makes your org unique, they layer that on top, and they make the base package a dependency of the packages that you're working on there. So you still get the advantages of working in this kind of very sort of modular, functional approach, but within the constraints of the Salesforce platform. We talked about version control, and that exists in terms of managing the versions of the code that you're changing, but also managing the versions of the delivered package. So you can say, okay, this feature is available in version 20, you need to go and install that. But behind the scenes in development, it may have taken you 84 iterations to get that code exactly how it needs to be. We talked about the dependency management. We looked at a sample dependency file there. These examples are in a GitHub repository. I will dig out the link for anyone that needs that. I might even post it on the Hoover app thing later. But you can see an example of how these things are defined. And there's also sort of great documentation on that. So that's dependency management. And then package promotion, we saw a sample GitHub action, which is reasonably portable to things like Jenkins, or even just like a shell script, or whatever way you want to do that. Just to kind of gather those pieces and bake it into your sort of DevOps deployment pipelines. This is a way of working. Okay, this isn't the way of working. You can do org to org, you can do org to Git repositories and vice versa, and all those combinations. Tools are available to work and deliver this modular functionality without using packages, But this is a way of working, and it works for a lot of people. And it's not like the folks you see on the App Exchange where they have to have a dedicated build org and they have to build managed packages and do security reviews and all that process. This is something that you can use today. And a lot of folks are using this, even admins. It's not that code heavy once you've got the infrastructure in place. It's a great replacement for change sets. And who doesn't want to replace change sets, right? So hopefully that's given you a little insight onto how you can incorporate some of these best practices into your lifecycle, how you can remove the stress of depending on everyone else's work and things being a little chaotic, and get something that's scalable. You can have all these packages into neat little modules, and you can deploy to any other org that you choose. And that's kind of what unlocked packages are about, really. We have a little bit of time left on the clock, somewhere in the vicinity of 3 minutes. So if anyone had any questions on that, I'm happy to pick them up.
How does it play with DevOps tools that are out there?
So the question for the purpose of the recording is, how does it play with other DevOps tools? The same way as any other changes would work, okay? So effectively, you're in the org, you're changing metadata, and you're moving it around, okay? So if you build a package, okay, it's just another container, it's another bundle of deploying those changes. But what you definitely want to be mindful of is, so I've done this development, I've built it in a package, I've now installed it into this org, and I've moved up and up. You need to make sure that you're remembering that actually, my other developer with his own developer sandbox may not have those changes. Now, there's two broad ways of doing that. They install that package, because these aren't like managed packages, right? If I install a package that has the Apex code in it, if it's a managed package, you can't see that code. If it's an unlocked package, as the name suggests, you can. So that's one way of doing it. The other way is to use those DevOps tools, whichever one you choose to do, and just make sure that you're pulling from source control. Source control is the key here, and you can propagate those changes back and refresh, not in the sense of refreshing a sandbox, but refresh the state of that sandbox by doing that and making sure that you've got that changes. DevOps is like 90% process and 10% technology. If you've got your process defined for making sure that you are regularly incorporating those changes back so that you're not overwriting them at a later point, you're going to be in good shape. It was a toss-up, but yeah, Ollie, go on.
Would you recommend for each of your modular dependencies, would you recommend different repositories for that, or would you have feature branches for every single one?
Okay. So again, for the recording, the question is, when you've got multiple of these packages, how do you organize your source control? Different repositories or subfolders within repositories or different feature branches? Again, we like to kind of meet people where they are. If they want it as separate repositories, we can do that. That's definitely in the package model. Yeah, that's absolutely possible. If you have a big monolithic repo, you can work that way, and people do, probably more than they do in separate repos. But yeah, try and have a bit of a subfolder structure in there. Feature branches should only be a temporary while I'm working on it. Spin up the branch, do the work, commit it, review it, do all the great testing stuff that we absolutely should be doing, and then that gets merged into your main branch eventually, and that becomes the canonical point of reference. But in terms of how you structure that while you work, in terms of where you keep the files, there's flexibility on that. You can work in both ways. And over that way.
When you were specifying the dependencies on the package,
yeah.
Can you specify between two versions, so say between V23 and V43?
Okay.
Or is it just the latest that you...
Yeah, so the question there is around the package versioning, which is that one. Yeah, I've been lazy and just said, go pick up the latest version, but you can absolutely, like so many other packaging systems on other platforms, say, I specifically want this version, or it needs to be greater than version 16, but less than version 21, because that's our beta trial thing. You can define that in there. I don't know the exact syntax off the top of my head, but yes, that is absolutely possible. So you can get very specific around your sets of dependencies. Okay, how are we doing for time, Claire?
You've got 1 minute.
Well, I have 1 minute. Who wants the honour of the last question? Nobody? Oh, yeah, there we go.
Kind of expanding on the question earlier, so if you've split up your
Yep.
And then you're making changes across all of them. What would the process look like to then get all of those different packages updated? Sounds like quite a lot of overhead, right?
Yeah, so the question there is if, extending the earlier question, if you do have multiple folders or multiple repositories for the packages, how do you bring it all together in a controlled sense? I genuinely, I don't think there is a tool on the market in the DevOps space that works with unlocked packages yet. So, the answer is not go out and buy our tool, his tool, whatever it is, because unlocked packages are kind of their own thing. What I would do is, personally, this script, the script that your friendly neighborhood developer has built for you, okay, extend that. So here you can see it's deploying the base package, it's deploying the dependent package, okay? So what will happen is as those scripts are triggered when stuff is committed, right? You're not going to commit to 6 different packages all at the same time within the same hour. So you get this incremental offset of when things are built. And as things grow and enhance, they get pulled in. All you've got to do is just update this script to say, okay, instead of the 4 packages that we were running on now, we've got 2 new packages. Let's just fold them into that script so that, and be mindful of sequencing, the order of what you've got to install. Because if you've got to install those dependencies in the right order. But yeah, it comes more to the build phase of, when I'm pulling in these packages, I just need to update that to bring in the new stuff. Hopefully that covers what you need.